Next example is our revenue and our cost equations and examples. So let's say we have Sally. Okay, back over. So Sally has a fixed cost of $1,000 per month. Let's say she has a variable cost of $250 per unit sold. And she earns $300 per unit sold and can sell a max of 400 units per month. Okay, so the first thing that we want to find is the equation for cost. So we can write this in blue. So we want cost, so C, as a function of N units sold. So that makes sense. It should be super easy. So we want our cost. We can isolate our cost parts of the information that we were told. We have fixed cost and we have variable cost. Those two are that apply to our cost. So C is equal to $1,000 every month plus an additional $250 per unit sold. So key thing here, our variable cost, we know to put the variable on because it says it right in the name. So that's why I have my X attached to my 250 and not my 1,000. So that was super easy. That's our cost equation. We're going to move that right up there for us. Now we want our revenue equation. Our revenue, we can write that in here. So revenue, which is R as a function, again, of N. And we know from up here is our units sold, so I'm not going to write that again. If you need reference, you can look above. So our cost has nothing to do with our revenue anymore. Revenue is everything that she earns, the money that she gets from every purchase. So we know that she earns $300. So all our revenue is 300x, which makes total sense because it's per unit sold again, just like our variable cost, so we have that x attached. Simple enough. Now you can graph these two functions on the same set of axes to see where they intersect. That intersection would be the break-even point. Instead of graphing this out, I'm going to show you that example, how to solve for your break-even point using the two equations. So break-even point, that's break-even. Break-even point is when C, which is our cost of N, is equal to our revenue. So 1 second, I'm going to go back right in here and just make sure I add my C of N. That's a key part because our function is our cost per unit sold and our revenue is our cost, or our revenue per unit sold. So C of N and R of N. Perfect. Now that that is all fixed, we can head back over here to our break-even point. So we know that our break-even point is our cost is equal to our revenue, where we've sold enough units that we no longer are losing money, but we're also not gaining money. So I'm going to write in our 1,000 plus 250x is equal to our 300x. So I just subbed in my cost equation and my revenue equation for C of n and R of n. And now we want to solve for x, the amount of units sold where everything is even. So to do that, we can isolate for x. Let's move this over here. We get 1,000 is equal to 300x minus 250x. We can move that back over now. And 1,000 would be equal to, difference is 50x. Then we are going to take our 1,000 and divide that by 50. So this goes into that. I'll draw that a little bit better. So divide both sides by 50, which gets us 20 units. So our break-even point occurs at 20 units sold, which is actually really great. Only has to sell 20 units in order to completely have no costs, but also have no profit. So speaking of profit, we want to know Sally's equation for her profit. What does she get for when a certain amount of units are sold? So for our profit, we're going to zoom all that out again. Can always rewind to review the information that we've already written. So profit. I'll write that in yellow. Profit is equal to revenue minus our costs. So profit will make P of n is equal to R of n, which is the money that we get from selling stuff, minus the cost per unit and our flat fee. So what we can do is go ahead and write in those equations. It's equal to that's our cost one, 300x minus 1,000. Put brackets around our cost. Remember, we're subtracting. 1,000 plus 250x. So factor in that 1,000 to get 250x. Perfect. Now, group like terms, we have our 300 and our 250x. Both have x's attached. So 300x minus 250x gets us 50x minus 1,000. So her equation for her profit can be used. So she wants to know if she sells 100 units, how much money will she make? Well, for example, if we sub in 100 for x, so P of 100 units is equal to 50 times 100 minus 1,000. So 1,000. Perfect. So 50 times 100 gets us 5,000 minus 1,000. $4,000. So therefore, profit at 100 units sold is $4,000. Remember, we don't have any units in our equations, which is why we write that final let statement. So again, we're just going to minimize all that. Bring us back over to our main section. Now, what value would Sally need to reduce her variable costs to in order to have a break-even point of, let's say, only 10 units sold? So the way we can do that is by taking our original break-even point statement. So we have that one right up here. So remember, cost is equal to revenue. You can go ahead and rewrite our equation in a little bit bigger. I'll write that in yellow. 1,000 plus 250, x is equal to 300. X. Now, of all of the numbers here, we want to reduce our variable cost. The variable cost in this equation is our 250x. We don't know what we're going to have to reduce it to, but we know our break-even point we want at 10 units. So we're going to change a few things around. The 1,000 is going to stay the same. That's our constant. Plus, remember, we're reducing our variable cost, which is that 250. We don't know what we're reducing it to, which is why it's y. We want to know at 10 units what it's going to have to be to break even. So we write 310 units. So solve for y. Sounds easy enough. 300 times 10 gets us that 3,000. So we can go y of 10 is equal to 3,000 minus 1,000, which is equal to 2,000. Make that just a little bit smaller. So 2,000. So to solve for that 10, we would divide everything, or to solve for that y, we would divide everything by 10. 2,000 divided by 10 gets us that $200. So our variable cost would have to go from 250x to 200. So $250 would be your original variable cost, and if we wanted to break even at 10 units, it would be $200 we'd have to reduce our variable cost to. So we can then write our let statement. Therefore, just box that off. Sally would have to reduce variable cost to $200 to break even at 10 units. That's just it. Completely how to do revenue and cost examples for sum and differences of functions.